In December 2011, the United States was operating one of its most advanced drones, a stealth unmanned aerial vehicle called the RQ-170 Sentinel, in Iranian airspace when all of a sudden it lost control of the aircraft. The $6 million UAV descended and landed in Iran. The Iranians captured it. They managed to decrypt the data on board and ultimately were able to reverse engineer the UAV and make their own version, the Shahed 171. This was one of the most painful and embarrassing intelligence failures that the United States had suffered in decades. And what happened? Why did this occur? It's believed that the Iranians hit the United States with an electronic warfare capability that the US didn't realize the Iranians had. Essentially what they'd done is to hit it with a 1-2 punch. First, they jammed it, flooding the electromagnetic spectrum with energy so that essentially the drone was blinded, couldn't hear its controllers from the US side. And then they did something a little trickier. They carried out what's called a spoofing operation. They injected false GPS data into the drone's navigation system, so the drone effectively had been lied to about where it was. It thought it was somewhere else, and so it landed, not realizing in its sort of machine brain way that it was landing in enemy territory. So this was kind of a historical moment because for the first time in history, an aircraft had been captured using cyber warfare techniques. In today's episode, we're going to learn about the threat environment that we now live in the wake of this attack, where things like this can happen. Who are the players? What are the capabilities? And what are the potential dangers that exist for the aviation system? And what does this tell us about what might have happened to MH370? Hi everybody, it's Jeff Wise back with you once again. For those of you who don't know me, I'm the author of the book The Taking of MH370. You might also know me from the Netflix documentary MH370, The Plane That Disappeared. We have a very special episode for you today. We're going to be talking with one of the leading experts in the field of electronic warfare and cyber security. We also have a community radar segment for you in response to a lot of the feedback and questions we got from last week's episode about hydroacoustic signals in the Indian Ocean. Once again, if you find value in this podcast, if you like it, it helps us a lot if you can subscribe, like, add a comment. These are all things that help the algorithm show the program to other people. As always, we're trying to get the message out, trying to help people understand what happened with this very important case. Another piece of news is that we have surpassed 500 subscribers, and that means we are now eligible for monetization. That means that you can subscribe for a fee. Obviously, this helps a lot, and we'd be very grateful for any help that anyone could give. We still have subscriptions over on the Substack, findingmh370.com. If you sign up there, you can also buy a paid subscription, and even if you don't want to do paid, you can just do a free subscription, and you get a monthly newsletter weekly newsletter that tells you what's going on in this week's episode and gives you a link to the video. Okay, so let's get to it. When MH370 disappeared in 2014, a lot of people didn't understand the vulnerability to cyber attack that modern airliners had. And that lack of awareness extended to the US government. In fact, in the wake of MH370, in April of 2014, the FAA hired a think tank in Virginia to put out a report, to carry out a study and issue a report on this subject. So in earlier episodes, I've proposed a mechanism by which MH370 could have been cyber attacked. Basically, the data that it sent to Inmarsat could have been spoofed. I had a very specific mechanism in mind, but reading this report really underlines that there's all kinds of vulnerabilities that existed at that time and continue to exist today. And this report kind of broke it down into different kinds of vulnerabilities. Here are some of them. One, manipulation of aircraft loadable software parts. That means that the boxes we've heard about, line replaceable units in the electronics bay, the software that runs them can be replaced, can be corrupted, and basically your malicious code can be inserted into it. Two, inadvertent or deliberate interconnection of aircraft domains during manufacture, maintenance, or modifications. An example of that might be if you let your passengers tap into the in-flight entertainment system, and there's somehow a connection between that and your flight control domain. That is a vulnerability that could lead to very significant problems. Okay. Three, manipulation of aircraft's digital design and software components during its design. For instance, what if you have an adversary who plants one of their operatives inside the design department that's building the plane or the software for the plane? Okay. And finally, insertion of backdoors or malware into aircraft electronic components or systems via the supply chain during manufacturing. This is a similar idea that not just the builder of the aircraft, but the suppliers of the subcomponents could be infiltrated, corrupted, etc. So obviously there's a much more broad and troubling set of vulnerabilities that exist that could cause problems for the aviation industry. And so to get a sense of the actual threat as it exists today and as it existed in 2014, I'm very lucky to be joined today by a leading expert in the field of electronic warfare and cybersecurity, Dr. Thomas Withington, who is a senior associate fellow at the Royal United Service Institute in the UK. He is the author of International Safety and Security, Counter-Terror, Cyber, and Resilience. He is an award-winning analyst and writer specializing in electronic warfare, radar, and military communications. He has written widely on these subjects for a range of specialist and general publications. He also works as a consultant and advisor in these areas for several leading government and private sector clients. So let's get right to it. Let's talk to Dr. Thomas Withington.
Jeff, it's a real pleasure to be joining you, and thank you very much for inviting me to have a chat to you today. I'm looking forward to our conversation.
Fantastic. Thank you very much. So how would you describe what you study and write about?
Well, I concentrate on electronic warfare, radar, and military communications. So I study those three areas. And
Okay.
I always tell people, rather than being an expert, I consider myself a very, very enthusiastic student. And
Okay.
it's been a set of subject areas that I've worked on for a number of years. I got very lucky later on in life to go and do a PhD that looked at the use of electronic warfare supporting military air operations. And so for a number of years, I've been writing, commenting, and performing analysis on those three subjects. And I've had a wonderful time doing it. It's been incredibly interesting, and every day is a learning experience, which is a wonderful thing.
I think that you were savvy to get into a field that had so much upside potential, because I think that it has become a very more important. And I want to talk to you about the trajectory that this field has taken. Before I do that, I want to ask you. You probably are used to meeting people at cocktail parties and whatnot, and they ask you what you do, and you have to explain, well, what is your kind of potted explanation for what electronic warfare is?
What I tell people, I must admit, I don't get to that many cocktail parties, but
Okay.
when I do, what I tell them is that armies tend to fight on land,
Hmm.
air forces tend to fight in the air, obviously, navies fight on the sea and by the coast, and space forces now fight in space. And we have to think about cyber, which happens in the cyber domain as well, cyber operations. The electromagnetic spectrum is where electronic warfare takes place, and the electromagnetic spectrum surrounds us. It surrounds the universe, in fact. And all of those forces, the land, sea, air, space, and cyber forces, must all use the electromagnetic spectrum in some way. And we use it in our daily lives for our phones, for radio, for broadcasting, for air traffic control, for a myriad of uses, just as the military are. So electronic warfare is about, in a nutshell, if you're one side trying to preserve your use of that spectrum to support military operations, whilst denying that to your adversary. So in a nutshell, that's what it is, and that's what I enjoy writing about.
That's fantastic. That's great. Now, for some people, this has come out of the blue. All of a sudden, there are these GPS spamming and spoofing attacks that we're hearing about, jamming, and this doesn't come out of, as we say in the United States lately, falling out of a coconut tree. This is something that's been developing for a long time, and we can't go back. Well, I guess the beginning, during the Russo-Japanese War, I think the Russians think that they invented electronic warfare because they were sort of interfering with telegraphic signals at the time that their adversaries, the Japanese, did, and they celebrate actually every April Electromagnetic Warfare Day.
Indeed, yes, they do 15th of April, public holiday. I would like to see a global public holiday in commemoration
Okay.
of electronic warfare as well. But of course, some people would argue I do have a dog in this fight.
Yeah,
But
yeah,
yes, you're right. The history of it is fascinating. I mean, the Russo-Japanese War is I suppose the acknowledged kind of starting point, if you like. But really, where we saw electronic warfare get most currency and come of age, I think, was during the Second World War, and that was mainly driven by air operations, and that was a need to, in the European theatre, it was a need to stop German radar being able to see RAF and US Army Air Force aircraft,
right,
stop German Air Force radio being used so that controllers can control fighters. And that was to give the bombers a fighting chance of getting through, hitting their targets and getting home. And then, really, throughout the Cold War and onwards, electronic warfare continued to gain in currency and importance. It was always something that happened in the shadows. It was highly secretive for a very long time. And when we moved into the first Gulf War in 1991, and then we moved into the Balkans Wars, and then eventually into Afghan and Iraq, we started to see more and more elements of electronic warfare enter the public discourse and enter discussion on news channels. And as your question mentioned just now, the question over things like GPS jamming has really thrust electronic warfare into the public consciousness, if you like. So it's been there for a long time. It's been there for well over a century. But I think now, because of our reliance on the spectrum, through our phones, for instance, and other things, it's something that the person in the street is concerned with, and rightly, and they should be. And that has meant that we're having more discussion, and that means more awareness, which I think is a good thing.
right. So in the evolution since World War II, where they basically only had radar, I guess they had some radio communications, but the number of manifestations was much smaller. You would say the surface area of potential attack is much smaller, but coming through the 90s and the 2000s and up to today, you just have this kind of exponential growth of applications of say on civil aircraft, you've got different kinds of devices on board every plane that are sort of, you've got like your radio altimeter that's measuring the distance to the ground on approach, and ADS-B, and I could just go on and on. And so as more and more systems come to rely on the spectrum, you have more avenues for chicanery, you might say.
Absolutely. I mean, a classic one that I always share with people is satellite communications. If we cast our minds back to the Cold War, satellite communications from the government and military point of view were something that was essential for them to be able to perform the work of government and to support military operations. But then we're also aware of it for broadcasting. For instance, watching big sporting events was possible because of the advent of satellite communications. And then obviously long distance calls, if you have relatives in the UK or you have relatives in America, it became possible to call them Christmas Day, wish them a happy Christmas. Of course, it was very expensive, but the prices came down. So I think one of the things that you've seen, and I suppose there is a symbiosis here, is that the growth of electronic warfare, the proliferation of it, one could say, has been commensurate with scientific and technological evolution and ingenuity. As we've used the spectrum for more and more things, so have adversaries and our own militaries as well, and our own experts sought to prevent the use of that spectrum by other people and by other organizations, for instance. So I think the two things are very, very tightly linked. You could say, in a sense, that all warfare is follows that similar matrix, that if you look at armored warfare, for instance, as propellants improve, as explosives improve, there's a commensurate improvement in armor. And that's also propelled by change in material science, for instance, as much of the armament will be changed and evolve by advancements in chemistry, advancements in physics, that kind of thing. And I think electronic warfare does follow that same principle. But it also follows the principle that there's a civilian element to it as well, because, as you mentioned just now, societies are so reliant on it. But it also is underpinned by the fact that in all conflict, innovation and ingenuity improves. I mean, that's the big catalyst always. So I think electronic warfare is influenced by those three things, scientific ingenuity, civilian uptake of technology, and the cauldron of war as an accelerant.
People might be more familiar with the concept of hacking, cybersecurity, that kind of thing. And there seems to me a kind of parallel between these two ideas, electronic warfare, sometimes called EW, and hacking on the other, where they're both kind of like the dark sort of anti-face of what's generally considered a positive technology, right? So you have this wonderful computer that you use to, check the weather every day, but at the same time, that is an attack surface that somebody can use to get inside your life by planting a, say, virus inside your phone or something.
Yeah, and there's certainly a gradual coalescence of the cyber warfare and the electronic warfare worlds. I wouldn't say there's a convergence, so to speak, because there are still some key differences between those domains. But back in the
Okay.
olden days, so to speak, you had two choices. If you had an enemy radio network that perhaps an army was using, well, you could try jamming it, which was just sort of transmitting a huge amount of interference. So the radios just hear static, they can't communicate with one another. A bit like, if you remember, I've got memories of having an internal aerial on the TV, and if somebody switched the central heating on or their car ignition went, there was this interference that used to come across the screen, electromagnetic interference, and that's effectively how jamming worked. Or the other thing that you could do is you could simply kind of hack into the enemy communications networks by listening in, right? What's being discussed? How useful is that intelligence? Can we use that just by the information? So the voice information and the data information that's moving around, so written orders, that kind of thing. Or, and this happened in the Second World War, you could put malicious fake radio traffic into those networks and cause dislocation. So immediately you can see the parallels with the hacking world. Hackers will try and steal information, or they'll try and put misleading information. We have the internet used a conduit for fake news, disinformation, that kind of thing. I suppose one of the key things, and well, I was going to say, I suppose you don't really get the jamming element, but if you have a distributed denial of service attack where you just simply take a network down, then that's very similar. So there are very similar attributes, I think, that both fields have, and they have this mystery. I mean, that's one of the things that drew me to this subject, was it was something quite mysterious, and I'm drawn to things that are mysterious. So I think there is a sort of correlation between the two worlds.
I wanted to ask you about the threat environment that we're in today, and I'm particularly interested in, well, I feel like Russia and China are sort of the two baddies, as at least as it's portrayed in the media. I want to ask you in particular about Russia. I had another guest that I was talking to about the sort of political environment, the international political environment that Russia found itself in, sort of post Georgia Georgian uprising. And my understanding is that around 2008, Russia really tried to reinvigorate its electronic warfare capabilities, and then in 2013 stood up a number of specialized units that were devoted to specifically using these capabilities. I was hoping you might speak a little bit to that.
Sure, yeah. I mean, as you said, you're absolutely right. 2008 was a watershed year for Russian electronic warfare, and that was propelled by two things. I mean, firstly, you had the war in Georgia, which Russia fought a short conflict in Georgia, and the shortcomings of Russian electronic warfare was a very valuable lesson learned for the Russian military. And that prompted not just the electronic warfare situation, but the wider performance of the Russian military prompted a need to reinvigorate the Russian armed forces writ large. And that was also propelled by a gradual atrophy that you'd seen with the Russian military from the end of the Cold War to the present day, where the money just hadn't been forthcoming, and that had prevented the ingenuity, and it prevented the procurement of the kit that the Russian military really needed, plus manpower problems and bullying allegations, which we all know about in the West, coupled with the wars in Chechnya, which were eye openers. So there was this immediate need to sort of arrest the decline somehow. And that saw a lot of electronic warfare systems, particularly for the ground forces, for Russia's armies and its allied ground forces, going into production and then equipping frontline units. But that was a bit of a double-edged sword to an extent for the Russians, because some of the systems that were entering service, they were new systems to the military, but the designs were not new per se. In some cases, they were designs that had been worked on, but then had been shelved during the 1990s as the money started to run out. And they were dusted off and sort of reactivated, for want of a better word, and put into service. So there was a hodgepodge of capabilities that were coming in, some of which were very, very good, some of which were not so good. But it indicated the direction of travel of the Russian military. Going back to your earlier question you had about the Russian Electronic Warfare Day, for instance, it reaffirmed the centrality of electronic warfare to Russian military doctrine and Russian military thinking. And that was a very important thing for them. And then as we saw, those systems went into war in Ukraine, first in 2014, and then an increased electronic warfare presence from 2022 when the second invasion took place.
So these were, and these units that were stood up in 2013, these were there was a number of particular units, vehicles, pieces of equipment that each of which was designed to do a special kind of task within the broader EW envelope.
Yeah, that's right. I mean, it's interesting with the Russians that they've, in many ways, chosen not to pursue general purpose EW platforms. So in the land warfare case, what I mean by a platform would be like an armored vehicle or a truck or something that has all of the electronics, it has the antennas, it has the power generation capabilities, the control cabins that are needed to perform the electronic warfare mission. And generally speaking, what NATO armies like to do is have one platform type, or perhaps one or two platform types, that can do many different tasks. What you've seen with the Russians is that they have tended to produce, they have many electronic warfare systems, all of which tend to do different things and have quite a niche set of capabilities. To give you an example, there's two systems, the Krasuka 2 and the Krasuka 4. One is designed to jam airborne radars, so to prevent NATO aircraft, ostensibly, that's who Russia sees the enemy as, from being able to find their targets on the ground and attack those targets using radar, using radar as the means of finding the target and then guiding a weapon onto it. And then you have another system that does the same job, but it does it in a slightly different section of the radio spectrum. So, just people may not be familiar with how the radio spectrum works, but you have it is a sort of finite resource that goes from one frequency up to another, and each frequency has pros and cons. Each set of frequencies has pros and cons. Some you can communicate for a very long distance, but you can't send much information through, and vice versa. So what the Russians have chosen to do is have many systems, each of which do a small mission set within the wider electronic warfare remit, let's say, which is a curious approach, but it does mean that they've ended up with a lot of systems. And that means the more systems you have, the harder work it is to destroy all of those.
Now, one of the other things that happened in 2013 was a Russian general, I guess you could say, Gerasimov. It's somewhat controversial, I think, to call to refer to the Gerasimov doctrine, but it's some people call it that. It's kind of a vision of conflict, yeah, which incorporates a wide variety of means of basically hurting your adversary. And EW is one of them, hacking is one of them, propaganda, targeted assassinations, all sorts of things. And I wanted to ask you about how you see the increase of capabilities that we've just been discussing, how that would fit into that vision of warfare.
Sure. I mean, the electronic warfare in terms of Russian military thinking arguably is one part of the country's wider information warfare doctrine. So it is part and parcel of that. It is information warfare that is executed against hostile militaries and civil society at the sort of the tactical and the operational level. So that's on the battlefield and in the theatre of operations, and in some cases strategically as well. So against, for instance, Russia has electronic warfare capabilities that are directable against US nuclear communications, so strategic nuclear communications. But you're absolutely right that it fits into this idea of either trying to deny your enemy information or trying to fool your enemy using disinformation or using fake news or whatever it is. I mean, we could talk endlessly about what those definitions are,
Right.
but it is very much part and parcel of that. It's a holistic approach. It's not just a case of destroying your rivals by hitting them with more explosive ordnance than they're going to hit you. It is about degrading their will to fight and their ability to fight. And at the end of the day, what electronic warfare is primarily designed to do is to prevent the enemy getting information through the electromagnetic spectrum. So a radar, for instance, gets you information by exploiting the electromagnetic spectrum. It sends a radio wave out, that radio wave hits something and it comes back. And by doing some relatively simple mathematics with measuring the time that radio transmission takes to go out and arrive back at the antenna, you can start to tell a lot of information about the target, and that will give you information about what you want to then do to that target. And equally, if you're moving radio traffic from one radio to another on the battlefield, again, you're moving information. So it's very logical for the Russians that electronic warfare is put into the wider information warfare remit. And as we've seen with that remit, it is huge. It's not just the electronic warfare that's happening in Ukraine at all of those different levels of war. It's things like interfering with elections. It's things like sending disinformation. It's sending fake news on Twitter. Sorry, X as it's called now. I lose track. All of these things. So it's a very logical approach from the Russians' perspective, I think.
One of the things I wanted to ask you about was the concept of cyber physical, in which the EW slash cyber capabilities can cross over into the physical world, manifest through physical action in the real world. And there was a famous case that happened in 2011. I think it's controversial. I don't know what your opinion of it is, but the Iranians managed to essentially hijack one of America's most high-tech drones, potentially using Russian equipment, and basically take it over and capture it, which, as far as I know, is really a great example of, I think, what cyber physical means, but also kind of a new era where you're not just denying your enemy's information or feeding misinformation, but you're actually physically taking charge of objects.
Yeah, I mean, first of all, I love the term cyber physical, it sounds like a new fitness craze, which is pretty cool. But yeah, I mean the Iranian takedown of the US uninhabited aerial vehicle is a famous one and quite an apt one, I think. And one of the things that you're seeing now is, in some ways, electronic warfare and the old school jamming that used to be done, or the use of radio waves to carry fake information into a hostile radio network. That's also now being used as the delivery system for cyber attacks. So you can use jamming to move, or use, let's say, a hostile radio signal, if you're the bad guys, for instance, to carry zeros and ones that are going to do damage in some way or enable you to take control of something. I mean, I think a classic example of what you're seeing where you're having a real world effect, we've seen real world effect from Russian electronic warfare, is what's been happening in parts of Northern Europe, in the Baltic, for instance, and down in the Eastern Mediterranean with Russian GPS jamming. And ostensibly that is being done by the Russians to protect targets against attacks by drones, against attack by weapons that require satellite navigation to hit their targets. But in protecting those targets, that jamming is having a real world effect in terms of causing disruption to civil aviation, for instance, in countries like Estonia, even causing disruption to ride-sharing services and food delivery applications, the sort of things that we use in our everyday life that people perhaps are not always aware of depend on GPS, for instance, or depend on other global navigation satellite systems. So that is, and it's interesting you mentioned the 2011 situation with the Iranian takedown of the US aircraft, because in many ways that was a portent of what is to come. And that's the sort of new reality we find ourselves in. It's not going away. And in many ways, these kind of attacks, or this physical manifestation of either cyber attack or electronic warfare, is only probably going to increase in the coming years.
I think the way that GPS spoofing works is fascinating and kind of metaphorical. In a nutshell, it has to do with the fact that planes use primarily inertial navigation. So they're measuring tiny changes in acceleration that are integrated over time to tell them where they are from moment to moment. And historically, if you use that method alone, your error increases gradually, and so you have a bit of drift. So by the time you get across the Atlantic, if you're flying New York to London, you might be some dozens of miles off course. So GPS was brought in to periodically cancel out that error by referencing it. So a lot of commercial aircraft don't use GPS by itself. They use it as a way to update and make more precise the underlying technology, which is inertial navigation. And the way that GPS spoofing works is by telling a small lie, a kind of very sophisticated lie. It requires that you know where your target is, and then lying to it a little bit and saying, you're actually a foot over here, because the system that updates the inertial navigation location it knows that it's a little bit wrong, but it knows that it isn't a lot wrong. So if you tell it a big lie, it will ignore it. But if you tell it a small lie, it will allow you to gradually move it off course. And I think this is believed to be the method that Iran used to capture the U.S. drone. It's a method that a researcher that I've talked to at the University of Texas at Austin used to capture a boat back in 2013. But it's this idea that it seems to me a fascinating overlap between what we would think of as electronic warfare and hacking, where you're basically, because you understand how your adversary's system works, you're able to kind of screw with it, basically. But it requires that knowledge of the adversary's system.
Yeah, I mean, the thing with GPS jamming is that there's a number of tactics that you can use with it. I mean, one of them is just straightforward noise, where you simply blast out the incoming signal. The signal coming from space is very weak by the time it arrives on Earth, so you don't need a huge amount of power just to prevent a GPS receiver from hearing the signal, if you like to, sort of use a human analogy with it. But the idea of, yes, just introducing that little bit of drift, that little bit of doubt, I mean, that is a case of just at the end of the day, you're receiving a code from a GPS satellite, which is a series of zeros and ones and binary, and by messing around with that, it is possible to create that dislocation and that disagreement between what the INS is receiving and what the GPS signal is telling it. I mean, another thing that I understood with the aviation situation, with the civil aviation situation, is that aircraft are now using, they're transmitting their location details, including their GPS position, across a satellite link to air traffic controllers. There's a system that the Federal Aviation Administration are now mandating in the US called ADSB, Automatic Dependent Surveillance Broadcast, which is going to become a global air traffic control standard. And why ADSB is so important is because, for instance, if you're traveling across the Atlantic, there comes a point where you are out of radar coverage. So, you cannot be seen for a certain distance because the radars on the coast of Newfoundland and Alaska and Greenland, and then down into the US, and similarly that are on the coast of the sort of Europe's west coast, you're out of their range. They can't see you. So this is a way of a controller being able to see where an aircraft is without that radar coverage. We unwittingly use it when we use things like Flight Radar 24, see where our flights are. We're getting that detail. So the problem is if you're starting to transmit unknowingly a false GPS signal, this is going to cause problems for controllers. I don't think, hopefully, and obviously I absolutely hope I'm right with this. I don't think it's necessarily going to cause a safety problem, but what it is going to cause is problems with the efficient management of air travel. And so that can mean things like, for instance, controllers have to separate the minima allowed between aircraft in terms of their distance from each other. And then that means you've got to space aircraft out at a longer interval. Spacing aircraft out then influences how many aircraft can enter a section of airspace at a bit of time. Extrapolating it further, how many aircraft can leave the airport that you're at in a certain amount of time, the frequency of departures. And this manifests itself ultimately with you getting a drinks voucher and having to go to the coffee place because it's going to be another 3 hours until you get your flight. Now, that's an inconvenience, and we'll grumble about it and we'll be cursing about it. But it has also an economic effect that causes economic dislocation. I don't think, for instance, the Russians at the moment are necessarily trying to cause that level of disruption with their GNSS jamming in the Baltic, but I think it's a very, very happy side effect for Mr. Putin that it is causing that. That's a sort of an added benefit from his perspective. So the GNSS situation and bear in mind, Jeff, we've just talked about air travel. If we extrapolated it then to all of the things we use it for, you start to see that this becomes potentially extremely problematic.
Well, one of the things it's used for that might be counterintuitive to people is for power generation and transmission, which requires very accurate timing of the electricity cycle. And I think in Ukraine, they really have had real problems because of Russian denial of GPS within the country. And of course, that is probably very much intentional. So you don't think that there has been some speculation that the jamming and spoofing out of Kaliningrad was less about, or maybe only partially about, air defense, since it isn't an active combat zone at the moment, but that it had more to do with just punishing Finland and Sweden for joining NATO.
I think it's a bit of both, actually. I just think it's, it is used that the Russians will be paranoid about an attack happening on Kaliningrad with a Ukraine drone launched from somewhere that is using, now the Ukrainian drones are probably much less reliant on GPS to reach their target. So the benefit of the jammer becomes questionable. So I think that's one of the reasons. But yes, I agree with you that this byproduct of the disruption it's going to cause elsewhere is going to be very welcome for the Russian politico-military leadership. And there's something that you touched on just now in your question, which I was really pleased you mentioned, because I think what a lot of people don't necessarily realize is possibly the most important thing we get from a GPS signal is a timing sequence. That's it. We get a very, very accurate timing signal. And all navigation is ultimately an exercise of measuring distance over time. How far did we go in X number of seconds, whatever it is. And so the moment you start to cause disruption to that timing signal becomes very, very problematic. I'll give you another application as well. Railway signaling, is dependent on having a very accurate timing signal. Sorry, railroad signaling, I should say, for our American friends. But you're having that a very accurate timing signal, and evolutions in railway technology, like things like moving block signaling and things, is dependent again on things like a very accurate timing signal coming from somewhere. So where's one of the places you can get that from? Where you can get that from a GNSS signal. So you're right. When you start to unpack it and you start to think, how many things do we depend on for this? This becomes an area of grave concern.
I'm fascinated by the duality of the creation of these technological applications, and in parallel, you have evil geniuses somewhere scheming. You had outlined the sort of damaging effects of a ADSB attack. ADSB, by the way, is like famously unsecured and unsecurable, and also the ground technology, the basis for a lot of other technologies like collision avoidance warnings. But I wanted to ask you about the kind of, you spend a lot of time thinking about the threat. And, to deal with a threat, you have to have imagination. We talk about white hat hackers, people who have the kind of criminal mentality to be able to imagine how to break in and cause mayhem. But in the service of preventing the mayhem rather than carrying it out. There's an idea, I don't know if you feel this would be relevant or not, but there's an idea I came across of advanced persistent threat actors. These are people who have sophisticated resources, have a long-term goal. They're willing to break into a system and just wait until the moment of opportunity arises. But is that something that, as you study the threat environment, you see that there are these APTs who are kind of out there, sort of plotting their plots?
I think it's interesting in the EW domain, because I think in terms of military on military EW, I think the threat from non-state actors is still relatively reduced, and the main reason I think that's the case is because the levels of things like communication and transmission security that today's military communications use, or the levels of security, electromagnetic security that radars have, for instance, it means that these are very, very difficult systems to jam and to attack and to exploit. It's not impossible, but the cost of doing that and of developing the technology to do that becomes difficult if you're a non-state actor. That being said, you are seeing manifestations of people using jamming technology, for instance, in the criminal underworld, for things like drug trafficking, for things like wildlife poaching in Africa, for instance. If you want to shield, if you're running a boat that's carrying drugs to a coastline and you need to navigate, or you want to shield what you're doing, then a good way of doing that is transmitting a false GPS signal that's saying you're somewhere else completely. We're seeing this, for instance, with Chinese fishing fleets using this, not just in the Asia Pacific region, but all over the world, when they shouldn't be going into exclusive economic zones, or where they shouldn't be fishing perhaps in areas where there's endangered species, that kind of thing. Sending false information across the maritime equivalent of ADSB is one way of doing that. But the level of sophistication is still smaller than what you would see with a state-on-state actor. That being said, go on.
I mean, when I asked about people with nefarious intent scheming in back rooms somewhere, I didn't mean to exclude state actors. I think that when you consider that possible drone takeover, I mean, clearly you had some very smart people in Russia building equipment that was then implemented by some very smart people in Iran. And yes, they are state level actors, but they're spending a lot of time thinking about what can we do? What is the way in? What is the gap in the perception of our adversary that we can exploit? I think that, I don't know if you feel differently, but it seems like the United States was really legitimately surprised to have their drone taken over. They hadn't thought that this would happen.
Yeah, I mean, it's an interesting one, isn't it, the drone takeover? Because I think that you never know also with militaries to what extent are you not necessarily watching the threat at the time. If you go back to, when was it, 2011, wasn't it, when that occurred? Obviously, we had wars going on. I think the US, I seem to remember the US had, I think, primarily disengaged from Iraq by then, but Afghan was still continuing. But we were fighting a kind of adversary. We were fighting what we thought was a relatively technologically unsophisticated adversary. So you then cut your suit according to your cloth, and there may be a level of thinking of, well, we don't need to worry so much about using a level of protection or a level of encryption or whatever it might be for the systems that could be hacked, that could be jammed, because, hey, we're not facing a particularly sophisticated adversary. Or equally, the intel picture screws up as well, and you're not aware that your adversary has the capability, in the case of Iran, to actually take over an uninhabited aircraft and force it to land. So I think it's a good example of what you're talking about. Yes, just having the eye for the main chance and going for it. I mean, there's a case in one of the things that is noteworthy in the electronic warfare world. It was in the 1980s and 70s and 80s in Northern Ireland. The Provisional Irish Republican Army got very, very good at countering British Army electronic warfare, and making sure that their bombs and their explosive devices were largely left undisturbed by the electronic measures that the British Army were taking. So it is always, I mean, EW is underpinned always by looking for that single point of weakness, that single chink in the armour that it's possible to then exploit for success. And I don't really see that changing. I think in many ways the vulnerabilities increase as our dependence on technology increases. And that just means potentially more chinks of armour. And this will bring me on to actually another point that I would make, which is why you have to engage the wider civil society and the wider political world on these questions. This is not just going to be something that affects the battlefield. It will affect us all.
I think that one of the most dangerous attitudes you can have in a kind of threat heavy environment is to think that your adversary is not capable of very sophisticated attacks, to underestimate your adversary, basically. I sometimes think about a village. I live in a village where it's pretty safe, knock on wood, and people, I shouldn't even be saying this, but people leave their doors unlocked. And I used to live in the city, and people definitely did not leave their doors unlocked. And it only takes a couple of burglaries for people to change the kind of security mindset to be like, okay, yeah, maybe I should start locking my door. And I feel like, in a way, civil aviation is in the process of transitioning from the unlocked to the locked door mentality. And in my reading, I have gotten the sense that some people in this space feel that it's time to start thinking about how do you bring pilots and ground crew and operational people into the idea that these things can happen. They might not have happened to you yet, or they might happen in ways that you haven't even thought of yet, but you should really start to get a little paranoid.
Yeah, I mean, I think a point you mentioned earlier in our conversation was really relevant about ADSB and the problems that ADSB has suffered and whatnot. And one of the problems always with the airlines, particularly, is everything is ultimately driven by cost. And ADSB, I often think, is a case of one of those trade-offs that you could have a system of the military that has a military equivalent of so civilian ADSB uses a system called mode S, which is we're getting very geeky here, but that's the sort of protocol that's used for civilian ADSB. And there's a military version of it called mode 5. And the key difference between those two systems is that the military version of it is encrypted. So what that means in practice is that if you wanted to somehow jam an ADSB system or somehow get it to transmit fake GPS data, you'd have to crack the encryption that the the military ADS-B signal, the military mode 5 signal is using to be able to do that. So that's a good degree of protection. The problem when you get into the airlines is it would probably be absolutely feasible and technically feasible to have something similar, an encrypted ADS-B signal that is safe from jamming and all of these things. But that is going to have a cost, and it's probably going to be ballpark figure 2-3 times the cost of what the current unencrypted civilian standard signal is. And I can just see it with the airlines that they will go, if we are not legally obliged to have this, we're not mandated to, we're not going to, because that will then mean, the passenger always can't speak today. The passenger always pays the premium. And that then affects their bottom line. I'll give you an example that you probably remember this from a few years back. Do you remember that there was a controversy and there was a concern about civil aircraft being engaged by shoulder-launched surface-to-air missiles?
Oh,
This
yeah,
was
very much so, yeah.
Yeah, so you remember back in those, that was a big concern. And there was a number of companies that came out and said, actually, this is a risk. We need to think about this. And we can fit a aircraft self-protection system that will neutralize these missiles as they approach an airliner. Well, yeah, the Israelis put it on their aircraft. Some civilian operators did, people flying VIP aircraft did, but most of the industry didn't. And that was driven by, again, cost. We're not mandated to have it. It costs $2-3 million per aircraft. The cost would come down, of course, the more aircraft using it, but it's still a cost. So we won't do it. So that's my concern. I think you would get a lot of people, to be fair, aircrew, ground crew, the professionals working in it, who say, actually, we do need this. This is going to be important, some way to protect our radio signals we depend on. But the bosses will, I think, always push back against it if there's a substantial cost imperative. And the sad thing with this is that the thing that would change it would be a disaster. That's always the sad thing. So, yeah, it is something we need to talk about, but I also see where the resistance is going to come in.
Yeah, I mean, that is an excellent point. And there are, as with the shoulder-launched missiles, there are 1,000 or 1,000,000 potential threats that you can imagine that you could spend money trying to counter. And until it materializes, it could be like the Y2K thing where people are going to be like, we spent all this time and money fighting it, and it never materialized. So how do we know to take you seriously? And that is truly an imponderable. I don't have an answer for that. But I do think that maybe one step that we can take, at least a baby step, is to just talk about, let's just talk about the fact that this situation exists, that there is a threat environment, that there are some bad actors in it, that there are vulnerabilities, and we might not be ready. Unfortunately, maybe we have to have a 737 MAX kind of situation where lives are lost until we really take it serious enough to start. And it might be too late, but whatever. At least we can sort of get out of the mindset of, and I think, frankly, people have been kind of poo-pooing the idea that there could be, vulnerabilities to worry about. So I guess that's why I want to talk with you today, is to at least try to interface, because there is a whole world, Tom, of people like yourself who study hacking, electronic warfare, cyber physical. There's an entire literature about it. But from my perspective as a general interest journalist, I don't see any crossover, really, into the general discourse. And so I personally have kind of feel a personal mission and desire to want to kind of bring out all of the stuff that's been on the other side of the fence back kind of into the public discourse.
Yeah, I agree with you. I mean, I think, to be fair, what you're seeing certainly in the US and in the UK and in Europe more widely is, I think there is a wake up. I think people are waking up to it, particularly at the political level. And that's certainly happening in the UK. People are talking about GNSS jamming, GPS jamming. What do we do if this takes place? How do we protect ourselves from it? So the conversation is there, and it's definitely occurring. And it's a case of now migrating that into the civilian domain, so to speak, the wider civil society. And I think that is gradually happening. I mean, the hard thing always with these things is that we're constantly asking the public to think about a lot, and we need to. We've had COVID, we've got climate change hanging over us, we've got threats to our democracies, the list goes on. It is an anxious time for people, and we add this in the mix. But then again, have the conversation now, and you avoid the disaster later. That's the thing.
We can, this is, I guess, maybe the overarching point is that we can deal with these problems, but we have to acknowledge that the problems exist first, and then we can start to make plans. We can start to use our imagination to sort of think, where could we be attacked? Where could we be put on the back foot so that we can mitigate against the worst?
Yeah, and to sort of think about alternatives and to almost have defense in depth, which is what the military do, which is okay, assume you won't be able to use the electromagnetic spectrum, so what are your workarounds with that? Or or have multiple systems that are redundant in place, so that the battalion headquarters has several radios rather than just one that can host the network. So if one of those gets knocked out for whatever reason, you've got another radio. Or if the worst comes to worst, there's no radios, right? No problem. We'll use dispatch riders and runners. We'll use carrier pigeons if we have to. You have these workarounds. So in the civilian, sort of the civil society side of things, that's right. Well, at the government level and the federal level for yourselves in the US, what do we need to think about? What are the important things to do? Right. Well, they're X, Y, and Z. This will keep the critical national infrastructure largely protected. These are the fallbacks. So that's that taken care of. So then down at the corporate level, right, businesses, what do you need to do to be able to ensure that you can provide your services, you can carry on trading, have a semblance of normality and things get back to normal, because it won't be permanent. And then moving down from that, right, NGOs, civil society, ordinary individuals, what are you doing? What's your protection strategy? If your cell phone, you can't use your cell phone, what are you going to do? And by doing all of that, that's how you build in your resiliency. And you'll probably find at the individual level, it's actually really small things you need to do, and suddenly, well, hey presto, that's your electronic countermeasure. You've used one of the pillars of electronic warfare, which is electronic protection. So there you go.
That's really great. Tom, I want to thank you again for taking the time to talk with me today. This has been really fascinating and really enlightening. And I appreciate your taking the time out on a beautiful sunny London day to talk with us.
But Jeff, it's been an absolute pleasure. It's been really good chatting to you, and I'm very pleased we didn't reveal the name of your village during our conversation. So I think you can still leave your doors open.
We had all of the bad actors, rubbing their hands, waiting for the opportunity to find them.
He could be anywhere in the US, guys, anywhere.
I'd like to thank Dr. Thomas Withington one more time. I'm very grateful to him coming to us all the way across the pond and sharing his expertise with us. I have a feeling I'll be tapping his expertise in the future. He's an incredibly fascinating and knowledgeable guy. Right now, I want to move on to the next segment, which is Community Radar. Had a huge response to last week's episode talking about hydrophone detections of noises right after MH370 vanished from the Inmarsat data. The expectation was that if this plane hit the water, whether it was a high-speed crash or even a low-speed ditch, either way, this should have made a noise that should have been detected. It wasn't, according to the researcher that we cited, who had a new paper out called Dr. Usama Kadri. There was a big response to this one. People had a lot of questions. Some of them I couldn't answer. I had to do a bit more reading myself. One of the was just, look, why are we hearing about this now? Certainly people must have been thinking and talking and writing about hydroacoustic data before this. And the answer is yes, certainly this is true. In fact, in the 2017 Australian final report on MH370, they had 3 appendices to that report that addressed various aspects of hydroacoustic data. And it's interesting because they pretty much just reinforced the picture that we got from Kadri's paper last week. But let me go through them just quickly, one by one. The first one is called Appendix H, Analysis of Low-Frequency Underwater Acoustic Signal Possibly Related to the Loss of Malaysian Airlines Flight MH370. And this looks at hydrophone data, both from the one at Cape Lewin that we talked about. Another one is a underwater sound recorder operated by the Center for Marine Science and Technology And this was in a location just north of Perth, a place called Perth Canyon. And it received a transient signal at 1:33 Universal Time. This paper basically concludes a detailed analysis of these signals has resulted in an approximate localization for the source of the signals that is compatible with the time of the last satellite handshake with the aircraft, but not compatible with the satellite to aircraft range derived from the handshake, which is being used to guide this search. In other words, what they're saying is it's not on the seventh arc. As you can see on the map here, it was much more in the middle of the Indian Ocean, very far from the seventh arc. So the conclusion is, yeah, we detected something. It could not have come from MH370. And there's noises in the ocean all the time. So the fact that you hear something at any given moment in time is not surprising, but it's probably not the thing that you know, in this case, MH370, it was not from that. Okay, let's talk about the second one, Appendix I. Results of analysis of Scott Reef IMOS underwater sound recorder data for the time of the disappearance of Malaysian Airlines flight MH370 on 8th March 2014. Okay, this has to do with a different hydrophone. It says the duration and frequency content of the initial high amplitude arrival are consistent with the signals located, again, Cape Lewin. So again, we're looking at Cape Lewin and another hydrophone. And again, what they found is that, yes, there was a signal. It was not located anywhere near the seventh arc. In this case, it was an event location that is near the geologically active Carlsberg Ridge, southwest of India. The location makes it likely that the event is geological in origin. So, again, not in the right place, probably some kind of underwater earthquake or something. Okay, finally, Appendix J, the third and final one. This is called Seismic and Hydroacoustic Analysis Relevant to MH370. And I want to particularly draw a line under this because viewer SK43999 referred to this paper in a comment, wrote, Kadri states that this event occurred at 0:52 Universal Time, but from his figure 9, it is event 2 in panel C, and thus occurred at a time of 0:54, etc., etc. He writes, Richard Stead, he's saying, Kadri states that it had an azimuth of 57 degrees, meaning it was off to the northeast. And SK4399 says, huh? Richard Stead of Los Alamos in July 2014 analyzed an event at 052, presumably the same data, and found an azimuth of 190.5 degrees, identifying it as an ice event from Antarctica. Kadri does not cite this report until these discrepancies are cleared up. The claimed 360-degree detection is of no value. Well, I don't know about that. It seems that Stead and Kadri analyzed this event very differently. They came to different conclusions. Unfortunately, it's above my pay grade. I can't tell you which one of them is right and which one of them is wrong. Maybe they're both wrong. They're definitely both not right. But regardless, no matter which of these bearings is correct, it's not MH370. It's not in the right location on the seventh arc, in the right part of the seventh arc, that it could have been a signal left by MH370 crashing into the ocean. So to sum up today's community radar, and to answer a question some of you are asking is, yeah, there's all this other work that was done that was cited in the Australian Found report. It does not seem like MH370 made a sound as it went into the water. There might be perfectly reasonable. There's always the possibility of a perfectly reasonable explanation, but you know, we should have heard it and we didn't. So there you have it. That's all I have for you today. Once again, thank you for joining me today. If you value this podcast, please hit like, subscribe, add a comment, tell your friends, send up a balloon with a streamer that says findingmh370.com. If you go to the URL there, and you can sign up for a newsletter. We now have paid subscriptions on the YouTube channel, which is very exciting. We continue to have paid subscriptions on the Substack if you want to support us financially. There are exciting things happening in MH370 world. I know you think that it's been 10 years and everything is dried and dusty. No, with the continued help of Keeley, our indefatigable researcher, and other people who are writing in and helping and offering their support, encouragement, ideas, and knowledge, we are doing interesting things. So stay tuned. More cool stuff is going to happen. For now, though, I'm going to leave you with my inevitable piece of advice, which is don't stop looking and don't stop asking hard questions. Thanks very much. I'll see you next time.